You guys seen it here first. Pretty amazing system, and I want to get your 2 cents on it, because I think just in trailer tire wear alone, safety, operators, this is going to save so many lives. I personally feel this is going to save a lot of lives. All right, guys, I'm in Brimley, Michigan at the Brimley Development Center, and this is one of the best kept secrets in the world. They actually don't want people to know about them because they do a lot of prototype testing, especially designed for trailers, trailer sway, trailer braking, all sorts of things like that. And they rent this facility out, but they also do specialty testing, and they're way back out in the boonies. Let's just go inside and see what's cooking. Okay, so I'm with Dan, one of the engineers, and Wendell from Hydrostar. What vehicle are we in, Dan?
We're in a Silverado 2500.
Okay.
2018 diesel.
And we are going to go 45 miles an hour, slam on the brakes as hard as panic stop, like a kid's crossing the road in front of us, and without cutting and editing, we're gonna go out and see if we flat spotted these tires. Tell me when you're ready.
Yeah. So we're getting up to speed now.
Okay.
45 miles an hour.
All right.
So we're just gonna go straight onto the brake pedal as hard as we can. You ready?
Yep.
3, 2, 1.
Maybe next time I'll wear my seatbelt. Okay. Now let's go check out these tires. We're looking for flat spots. So we are gonna see rubber on the road, but are we gonna find a flat spot? We got 4,000 pounds in the back of this trailer. So as we look at these tires have been doing this for days and days. Now look at the road. Look at here. Yes, we do have rubber on the road. We don't have a skid. We don't have a flat spot. We haven't destroyed these tires. We've evenly wore the rubber off from the entire tire casing, meaning when you're done with this panic stop, you're not going to go down the road going thunk, 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 hitting that flat spot. You're going to be able to go down the road and you just saved yourself $800 in tires. What's the next test?
So next we'll ramp it up. We'll go a little faster. We'll do it at 75 miles an hour.
75. I am going to absolutely wear my seatbelt this time. All right, guys, in a moment we're going to show you something that it is a game-changing. This is the guy that invented this. Tell me why you created this in the first place, Wendell, and who are you, by the way?
My name is Wendell Hansel. I'm the owner of Hydrostar.
Okay.
We wanted to have the best trailer braking system offered in the world, and you know, the biggest problem is everybody has problems with flat spots and tires.
Yep.
Delays, inadequate braking systems for guys that are traveling all under Class 8, hotshot guys, RVs, boat trailers up and down the roads, and we wanted to come up with a system that was lights out, instant activation with full ABS capabilities. And
this was your brain baby how long ago?
Well, I don't know. We had a premonition about 10 years ago. And Ralph at Continental / now Movia came to help us with it, and we worked together with them, and we've been working on it. This is our third go around, our third try, and I think we got it right this time.
And you created a system that will perform on ice, on sudden stops, on 75 mile to 0 stops, swerving, and we're going to be testing all of that.
Panic stops, no problem. Ice, no problem.
We're going to be putting it through every single pace that we can think of and throw at it.
Absolutely, and being able to activate the brakes as soon as you're hitting your brake pedal on your vehicle.
All right. Well, it'll be interesting to see how well your engineers and you did.
Hopefully you did it right.
All right. Let's go.
So
this is the same ABS system that is in cars and trucks right now,
yes,
right, Wendell?
That's correct.
Okay. So this is the test track up in Brimley. This is a private test facility, and we're just coming around here at 75. We're going to hit 75 miles an hour, and then we are going to panic stop with everything this has. Boy, I hope that 4,000 pound block is secured pretty good back there, boys.
We picked our best chains.
Hopefully we don't break the welds.
60. This isn't where we hammer it down yet. Seatbelts on.
All right, so now we're truly going interstate speeds. We're at 75 miles an hour, and we're just going to do a panic stop. So
Okay.
we're in the middle of a conversation, not paying attention. Something's in the road. Full stop.
All right, let's go see if we have flats. I can smell the brakes cooking. I can smell the brakes cooking. Hey, Dan, can you roll forward just like 2 feet? I want to see if we got a flat spot. Zero. Perfect. So you can see where we slammed this entire time. And that's normal. To have that rubber be laid down on the road means your brakes are your tires are consistently stopping, but they're not grabbing and skidding. You got to see what it feels like inside the truck. Let's watch it from outside the truck. 75 mile an hour panic stop. Holy crap. These guys get to do this every day. Bessa's like, yes I do, yes I do. Nothing. What's next?
Well, next we might add a little more excitement to it if you're up for it.
Sure. What do we got?
So
Ice.
Ice?
Ice, baby.
All right, so up here in Brimley, they have an ice, they simulate ice.
Seatbelt. We don't want to get Dan in trouble.
Well, what we're gonna do before we simulate, I wanna show these guys how slick this is. So, because, I mean, yeah, it's 22 degrees out today, and yeah, it's cold, but this is a wet water track with a special tile, right?
Yeah, there's ceramic tiles with some sprinklers going up them.
Okay, and so this simulates ice, and it really is just like
so this is pretty standard in the automotive industry, where we run water across tiles to validate our ice testing without having the true surface.
Can you go onto it, and then I want to show these guys what it takes just to take off from this, so that these guys know that we're truly going to be on some really slick surfaces.
Yeah.
Well, thanks for letting me out right in the water, Dan.
You're welcome.
All right, go for it. Okay, so this is a 25 mile an hour full stop on full ice.
Yeah, so we're gonna start braking just before the tiles, so that way we build up the brake pressure in the system, and as the wheels lock up, we're gonna have to evacuate all that pressure and let the ABS dump the pressure so that the vehicle is stable. It'll still come to a stop. So, right?
No loss of control. So Dan, it's that ABS system's allowing you to maintain control when you're, now are you coming to a full panic stop when you're doing that, or what?
So that one I was actually doing normal braking as a transition, because the amount of pressure that's in the system when you're on the pavement is acceptable for that surface, but then as we move to the ice, there's not enough friction available, so the wheels immediately lock. So we don't need to do a panic maneuver to get into full ABS event on this lower rim surface.
Ah, okay. But the ability to maintain control is part due to the ABS system compensating, correct?
Absolutely, yeah.
Okay.
We have to get that pressure out of the system, and then the wheels can recover and roll at a predictable, stable rate.
Okay, thank you. Okay, so now this test, Dan, tell me what we're gonna do here, will you?
So we're gonna do another panic brake apply at interstate speeds, but for this one, we're gonna add a single lane change. So what this simulates is another panic stop on the interstate, But now, instead of being able to stop short of whatever's in front of you, be it traffic jams, we're actually going to go and we're going to take that next open lane to the side.
So imagine you're like the oh crap, and you got to switch lanes while you're braking. This is like the recipe for.
Yeah. And so this is normally a no-no with a trailer, but so what we're going to go for is, if you're ready, we're going to go
ready.
3, 2, 1, panic brake. We're going to grab that next lane, steer back in. Everything's under control.
Ah, it's like these guys, they're reading my mind. Let's see what it looks like from the outside when we do a 75-mile-an-hour panic stop with a lane change. And now you've got to realize there's a 4,000-pound cement block in that trailer pushing that truck forward simultaneously. This is the recipe for disaster that hurts a lot of folks. Let's see how this new ABS system can handle it. All right, to get up to the proper speed, they go all the way around the test track. Then they come cooking down here, and right here they're gonna, and we're gonna stand right here and watch them. Because why wouldn't we? All right, here they come. That truck is cooking. Unreal. Unreal. That's 4,000 pounds in the back of that trailer. All right, here he comes. All right, here he comes. 75 miles an hour. Trailer is empty. He's going to slam to a stop as if he's not paying attention on the road. And he's got to suddenly swerve, and we're going to see exactly how well this handles from 75 to 0. Can you just roll forward a foot? I want to see how these tires are. Now this is a prototype trailer that they allowed me to do as much testing as I wanted to on this. So yes, we ran every test over and over again, and this is a different view of the 75-mile-an-hour lane change with panic stop. Alright, I'm gonna hop out. Don't go anywhere, Bess, okay? How many times has this specific trailer done this?
Today alone?
Today
probably
alone.
About 20.
So, now this is called, I guess, a mu split. Maybe I'm probably butchering that like I do everything else. He does have to compensate in the steering for this, but watch. What makes this especially challenging is half the truck is on ice and half the truck's on dry pavement. So the brakes have to do all of the compensating. Got it.
Yeah.
Gearing up.
All right, here we go. We're gonna watch the trailer from inside the cab. All right, guys, I forgot to film something, and that is the difference in gain and the difference in the truck. So the ABS system basically does everything for you. Let's put this down to 3. So we've got our gain set at 3. We're gonna go up to 45 and we're gonna do a full panic stop. Check the tires for flat spots. Right, Dan the man?
That's right.
And then we'll, I'll turn around, get better speed. And then we'll put the gain up to, let's put it up to 9. And then we'll give her another full hit stop. And then we'll do a 75-mile-an-hour lane change panic stop. Oh crap, something's in the road type of a scenario. So let's do it. Okay, 45, gain at, let's go. Okay, without changing anything, let's keep the camera rolling. Let's see if we flat spotted this empty trailer. Trailer is empty now, so we've taken the full load off. This is where we should see flat spots. And we've got nothing. Okay, that's at 3.5. Now let's go.
So, I hate to interrupt you, but can we film that going the other way so we don't have that vehicle in the background?
Oh, you don't want to see your top secret vehicle?
Yeah, we don't want to film our other projects.
Dan's got top secret stuff going on. Okay, gains up to 9 at this point. All right, 45, full panic stop coming up. Gain 9. All right, let's see how that works. When you look closely at the skid marks, you'll actually notice those are from the truck and not the trailer. Nothing. 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 That's on an empty trailer. Didn't matter if the gain was at 3. Didn't matter if the gain's at 9. The system does all of the compensating for a guy. All right, guys, you've seen it. Ralph, what do you do for these guys?
So I'm basically the brakes and chassis engineer for the trailer brake system. So basically what this is a retrofitted automotive grade brake controller into a trailer. So hydraulic ABS.
Okay.
So it uses the hydraulic brakes. So we have the calipers and the disc brakes. But in order to make the ABS work, we have tone rings and wheel speed sensors. So I don't know if we can see it. In there next to the caliper, to the brake line, we have that other black wire.
Do we got it right here? We can look at it?
We have it right here too, yep.
Okay.
So this here is the wire that goes into the wheel speed sensor.
Okay.
It goes to the bracket. And here, if you come in from this side, you can see the tone ring in here. And that basically shows you the ticks. So it's 54 teeth on this. And that shows the system what the wheel is doing individually for each wheel. And that means you can regulate the pressure on each wheel separately from each other.
But what does this mean to the end consumer? You were telling me that now when you apply the truck brakes, the trailer brakes will apply within 1/100th of a second?
A tenth of a second.
1/10 of a second.
Yeah.
So almost simultaneous.
Pretty much, yes. So I mean, it feels like in the truck you hit the brake pedal and you can feel the trailer brakes come on right away. So there's a very, very slight delay, but it's almost not really noticeable.
But now, you're not reinventing the wheel with this thing, Ralph.
No. So the controller here, so this is basically the heart of this. So this is the hydraulic electronic control unit.
That's in Mercedes-Benz, that's in Ford.
That's in, like, Ford Explorer, for example, is one car. This is in
I mean, this
series
like
production.
is the actual unit that
Yes.
comes out of those, and you used it in this system.
Correct. So this is a automotive grade, proven FMVSS approved controller, but it's repurposed for the trailer application. So obviously the software is different. It has a little bit of rework, but the hydraulics, all that stuff is the same. And one thing we can see here, it's a one box design. So the brake reservoir for the fluid, the computer, the hydraulic block, and the pump motor are all in one combined unit. So you don't have separate pieces all over the trailer. And you can see you have 4 individual brake lines. So that means you can control each wheel and the pressure to it individually.
And that's how you were able to keep control when we were on the skid pad.
Correct.
The operator didn't have to oversteer worrying about what was happening with the trailer because each axle was operating independently.
Well, not just each axle, each wheel.
Each
so
wheel,
if you're,
that's what I meant.
If you're on the split mule where you have half of the trailer on a high grip surface, half on a low grip surface, that means you can dump the pressure on the lower grip surface to not lock the tires, and therefore you can keep the trailer straight.
But now it's not all right here, it's also here.
Correct.
What is this?
This is the so-called interface module, and the reason why we have this is so we get an analog signal from the truck, which is your blue wire, the 0 to 12 volts, and that gets into the trailer, normally actuates the brakes, but since this is an automotive grade component, it needs a CAN signal, CAN bus signal to be triggered. So what this module does, for one, is it converts the analog signal, so the 0 to 12 volts, into a brake request in percent, 0 to 100% to the brake controller, and then that actuates the brakes. Your gain still works, so that still changes the application. Your breakaway works through this, so if you pull the breakaway pin, that actuates with 50% brakes. And this also then gets the warning lamps and the diagnostics from this unit. So if there's a fault in here, you can trigger warning lamps that in a production would be mounted somewhere in the front of the trailer, so you can see it in the rearview mirror, and it would be able to diagnose, so you can plug a scanner into it, and then if you have any faults, you can read the faults, clear the faults, and then do the maintenance. Or if you change the pads, you can relearn the system afterwards.
Tell me about the future of this. Where do you see this? What are you going to be doing with this? Is it going to be standard on every trailer? Where is this going? Where is this headed, Ralph?
Well, so if it was my wish, it would be on every trailer and it would be mandated. But for now, I think it will start in the more expensive trailers. That's just, you know, because it's an expensive system at the get-go. But I see this in RVs, travel trailers, the big gooseneck hotshot trailers that haul expensive equipment, expensive boat trailers, race car haulers, that type of stuff first. And then it might trickle down from there.
Now, straight out of the factory installed, or is this something that a person could retrofit themselves?
You could do both. So I mean, obviously it would be an option for some trailer manufacturers to incorporate that, but since the system relies on disc brakes, and currently there's disc brake conversions out there, you could retrofit this to a standard trailer you already have right now. That would be possible.
So what you do here is we take these 4 brake lines, we come out, and then we go to each
wheel, and each wheel, the wheel speed sensor also feeds back into the unit. So that means we have one hydraulic line running to each wheel, and we have one wheel speed sensor from each wheel running into the controller, giving live feedback of what the tires are doing.
Okay. What else do we need to know about this system, Ralph?
Well, so this system, for one, again, it's automotive grade, so it's been tested, shockproof, salt spray water, cold weather, hot weather, so it's a full automotive grade system. It is a 2-circuit system, so you have front and rear axle separate, so if you lose one circuit, that means the other axle is still capable of braking, and it's still capable of braking with ABS. And also, the system is smart enough to detect leaks, so if one caliper leaks, it can detect that and it can just isolate that one wheel. And that means you can still run brakes on all 3 remaining wheels and just isolate that one, and you're not dumping all the fluid out over time.
So why did it seem like it operated the same no matter where the gain was set at, Ralph? It didn't make a difference if I had the gain at 3 or I had the gain at 9. Why?
Well, because through the wheel speed sensors, it detects slip on the tire, and it's going to give you pressure until it notices slip. So as long as the tire has enough grip, you can put as much pressure in there as you want before the tire slips. And so that means if you set the gain higher and there's more pressure available or more grip available to make the pressure work, that's why you can set it to a higher gain without locking it or doing anything different. And if you set it at a lower gain, it's still going to try to get you to a certain limit of where the tire starts to slip.
All right, guys, I'm going to jump in here because this is kind of an important point, and Ralph the engineer wanted to clarify this a little bit further. And so I'm going to read you exactly what he sent me verbatim. Now, The reason why you did not feel a difference between gain 3 and gain 9 on the empty trailer is based on the available grip level. On gain 3, the system stays right at the maximum grip level for the empty trailer. It is set so that at 100% brake request, the ABS just starts to kick in. If you over brake the empty trailer with gain 9, but the grip level of the tires stays the same, the system will go into ABS, resulting in the same brake performance with the available grip level. All right, now back to your regularly scheduled program. And as we look at this, I can actually see where you have the input for the actual brake controller here. So
Correct.
This is pure prototype at this point. What changes do you see happening as you move forward with this?
So one change would be that we get rid of the pedal rod, because this is technically where your brake pedal would mount, which in this scenario we don't need anymore. So this would be something where you just have it capped off, be a little smaller, easier to mount.
Gone.
Yeah, so anything beyond here would be gone, and it would just be capped off. And another thing to note is that this system right now is ABS, but by adding an inertia measurement unit, so sensors basically, you can make this sway control capable. And it's not that you need to buy a new unit, you can flash a new software on it as you add the system to it. And then you can retrofit an existing ABS trailer into an ABS and sway control trailer. And another thing is that this unit is capable of triggering EPB, so electronic parking brakes. So that means you could add different calipers to each wheel, and you could then have an electric parking brake. So you just have a switch here in the box somewhere. You hit that, it locks the brakes. Hit it again, it opens it. For one, makes it safer for loading, unloading, but also a theft prevention, because once you hit the brakes and you lock the box, nobody's going to drag the trailer away. And then another thing is the breakaway could also work together with the parking brake. So that means once you come to a stop in a breakaway scenario, you could just clamp the brakes, and then it could stay forever without draining the battery or anything like that.
But now let's get it very clear. If we're going to try to retrofit, if a person wanted to get in there and retrofit this for himself, he's not just slapping any old ABS system into his box, because there are people that have done something similar to that, and they kind of work.
Kind of works, yeah.
They don't work to this level. What you guys have done is you've incorporated the brain box, you've incorporated the controller, but then you actually have taken it further where you've brought it right down to the axles themselves. So if a guy wants to do this, he's got to swap out the components in the axles.
Yeah, like the hubs.
The hubs.
And add the wheel speed sensor to it.
Yes, so there's more to this than just those two components. It's everything working in unison.
And one thing you touched on too with this is, so it's not a one size fits all. So depending on the tire size, the brake caliper that you have on the unit itself, the software will be different. So you will have basically parameters you can change to dial this in. So there will be a base software that all controllers have, but then depending on the exact application, weight, tire size, brake volume consumption on the caliper, we can calibrate this so it gets the maximum performance out of that system on this specific trailer. So it's not like you just throw something on there and it somewhat works, but it actually works perfectly for that specific application.
Okay, down the road, what do guys do to see how this is coming along in development? Where would they go? Do they follow along at Hydrostar? Where would they go? How do they keep track of this?
Hydrostar will be the ones posting more videos, and we'll do some comparison to other brake systems, and they would have that information updated as this moves along.
So follow along at Hydrostar to see how this is coming along, because this has been 8 years in the development.
10, yeah.
10? Okay, yeah. And this is the first this is first time being out in public.
This one. So that's the second iteration. The first one has been shown a couple of times, but this is the first one that full-by-wire system has been shown.
All right, and you're going to have that on your website, Wendell?
Yes, sir.
What is the website?
HydrostarUSA.com.
One more time.
HydrostarUSA.com.
All right. Did we cover everything, Ralph?
I think we did, yeah.
All right. You guys seen it here first. We had a lot of fun. It's a pretty amazing system, and I want to get your 2 cents on it, because I think just in trailer tire wear alone, safety, operators, this is going to save so many lives. I personally feel this is going to save a lot of lives. After seeing what this is capable of doing. And after, now it's your turn. What is your thoughts? And that's it for this video. God bless, and go get them, guys. We'll see you on another one.